Welcome to all. This is part 4 of design of shear reinforcement for beams. Part 1 and part 2, they were for when shear reinforcement was in the form of only vertical stirrups. Part 3 and part 4 are when bent up bars or cranked bars are available for resisting shear, written here. But remember, finally design is using vertical stirrups only. See, usually, practically, always vertical stirrups. If cranked bars are there, use their strength so that some relief for the stirrups, that's all. So stirrups are always there. Okay, now, question before that one. Those who want to understand everything, part 1, part 2, part 3, thoroughly your study. Cannot come directly to this class and tell something is not clear. It's a continuation. Okay. Question 2A. Actually, some problem were there. I recorded twice, but number confusion, so I changed it once again now. 2A. See, question 1 was earlier. That was when the design was using only vertical stirrups. We did 3 questions. One question, it came unsafe. Second question, shear reinforcement was not required. Last question, it was required. Last important. In question 2 also 3 questions. Same thing here also. So here also 2C is the most important. But study everything. Okay. Question. I will dictate. The cross section of a RC beam considered for design of shear reinforcement has width of 250 mm, depth of 500 millimeter. For that cross section, tension reinforcement provided is 2 bars of 20 mm diameter at effective cover of 50 mm. Also, given in the question, 2 bars of 16 mm diameter are available for resisting shear for the cross section considered. 2 bent up bars or inclined bars or cranked bars are available. Taking M25 concrete and Fe415 steel, design shear reinforcement using vertical stirrups if for the cross section shear force is 240 kilonewton. Okay, over. Start. All this data I told, B, D, A, T, etc. also given 2 bars. Okay, now this will come later. See green color. First, as usual, nominal shear stress tau V equal V by BD. Something I told earlier, write it. It will come 2.133. So tau V, then shear stress is 2.133. One note, cross section should be able to resist this stress. M25 concrete from table 24, tau C maximum 1.9. By looking you can tell what is tau C maximum, you should write referring to earlier class. Oh, shear stress is beyond the limit, so not safe. Cross section provided not okay based on shear, therefore cross section to be redesigned. Our example is over. Somebody will ask, how to redesign? You redesign the cross section so that tau V comes within tau C maximum. Then what to do? Then wait for next questions will come. When tau V comes less than tau C maximum, further questions are coming. Okay, refer that one. Over. Now, somebody may ask, sir, in the question you told cranked bars are there. Sir, where are they? What cranked bars? First of all, cross section is not safe. First of all, we are not going to design shear reinforcement here. Why? It is unsafe. Therefore, that question will not come. You tell useless. First of all, the cross section itself is unsafe. Like, you have 2 lakhs with you. I told you, your friend told he will give you maximum 8 lakhs. So, including his help, you can buy up to 10 lakhs. But you want to buy a car of 15 lakhs. No, not possible. Some other arrangement you have to make. Here, redesign. So don't make any arrangement. Don't call the friend and ask all these details. Why? Even if he gives his help, you cannot buy it. So, over. This already I told earlier. Okay, now, question 2B. I will do one thing. Just now I wrote it, then I have problem. So what I will do is, I will write the question, everything, then I will continue. question 2b, I will dictate. Rectangular section of RC beam has width of 300 millimeter and overall depth of 600 millimeter. The cross section considered for design of shear reinforcement has tension steel in the form of 3 bars of 25 mm diameter at effective cover of 50 millimeter. Also, 2 cranked bars of 20 mm diameter are available for resisting shear for the cross section considered. Taking M20 concrete and FE 415 grade steel, design shear reinforcement in the form of vertical stirrups. Over. This all should be clear. B I changed D, AST changed, this all over. All statement I changed here. Tau V will come. One thing forgotten. In the question given. Design shear reinforcement for the reinforcement in the form of vertical stirrups if shear force for the cross section is 60 kilonewton. I forgot. Okay. Anyway, you can see here. Okay, start. V by BD, get the answer. 0.364 will come. M20 concrete, 1.8 Newton per mm square. Therefore, this time your tau V is less than tau C maximum, safe. Or cross section provided is okay based on shear. You can note here. We can proceed further. Next step, you have to get tau C. What is the permissible stress only for concrete? You require this all already over. Percentage of tension reinforcement provided 100 AST by BD, that will come 0.892. I am not telling more details because it is a repetition. Those who are serious and understood everything, they will understand. That is what I want. Now, table 23 for M20 concrete, PT and tau C given, interpolation, you get tau C by linear interpolation. Now compare tau V, 0.364, tau C, 0.373. Actual shear stress is 0.364. Concrete alone can resist 0.373. Therefore, shear reinforcement is not required to be designed. Not. So what to do? So even if it is not required, however, provide nominal or minimum shear reinforcement at a maximum permissible spacing. This all I told you last time. 1, 300, 0.75D, ASV FY by 0.4B, FY not to be taken more than 415. ASV is cross-sectional area of legs of the stirrups. You write there, pi by 4 of 8 square, because we are proposing what? 2-legged 8 tor. Pi by 4 of 8 square into 2, it will come 100.53. Substitute, spacing will come 302. 3 values are there. Only one value you have to select. Among all these 3 values, IS code point of view, maximum permissible spacing is least of all 300. So provide 2-legged 8 tor vertical stirrups at 300 center to center. Or money matter. You have 2 lakhs. Your friend told I can give up to 8 lakhs. Last time, so including his help, you can buy up to 10 lakhs. Last time what happened? You thought of 15 lakh car, so idea dropped. Now you want to buy a car, second-hand car, for only 1.5 lakhs. Then your friend, you will think, why should I ask help? I myself got 2 lakhs. So help is not required. See, shear stress is 0.364, whereas 0.364. Concrete capacity is 0.373. This all I told earlier. So provide nominal. Once again, right here. Once again, question can come. Sir, what about those cranked bars? No. First of all, shear reinforcement is not required. When shear reinforcement is not required, what is the use of cranked bar? Let it be there. No, it is there. No, it is there. Let it be there. What you are losing? Let it be there. Don't worry, bother about it. Over. Now, the most important question right here. The purpose is most important question to see. This is where shear reinforcement is to be designed, and now you have to consider cranked bars. Once again, I will first write here. Otherwise, what happens is somewhere there series of numbers are there. Before the class, I noted down. I can understand. I will show you if you want. See, For me, I don't bother about which is what. I'll show you how I write it sometimes. See, you can see like asteroid belt between Mars and Jupiter. Scattered numbers are there. You can see there. I can make out which number corresponds to which one. So when I look there, I can make out. But what happens is, suddenly number gets mixed up. That's why problem. So I will prepare the question, then I start. Abba. Abba. It wobbled. Okay, luckily. Okay. When I moved there, it hit the stand. Okay, no problem. I will manage it. Luckily, no damage. Okay. Running? Yes, running. Sometimes these things happens. Okay, now, question number 2C. Question dictated. Remember, the most important question. Question is, design shear reinforcement for a RC beam if the cross-section considered is subjected to shear force of 200 kilonewton, and that cross-section has width of 200 mm and depth of 550 mm, and tension reinforcement is 2 bars of 25 torr, effective core of 50. I am not changing because this is already known for you. Okay, then take M30 concrete and FE 500 steel. Shear force I told 200 kilonewton. Now important, in the question given, 2 cranked bars of 16 mm diameter are available for resisting shear for the cross section considered. Okay, start. All this I change now. B over D over AST, correct? M30, okay. Tau V will come 2 Newton per mm square. I just that's why some stains are there. And M30 concrete, tau C max 2.0, narrowly escaped. Like you can buy a car up to 10 lakhs, you want to buy a car of 9.8 lakhs. Yes, you can proceed further later. Tau V less than tau C maximum, safe. Cross section is okay, little critical. Now proceed further to get tau C. What you have done last time, do same thing. 100 AST by BD, 0.982. Table 23 for M30, get the values, interpolate, get tau C. Now tau V is 2. Tau C is 0.407. This 2 is not your 2 lakhs rupees 2. This number Newton per mm square. Okay. See now. Tau V less than, not less, it is more. Previous is there. Tau V is more than tau C. Means the shear stress is more than capacity of concrete. So shear reinforcement is required to be designed. Over. Now I will continue because full board I require now. I will continue. Now 1 minute now. This is for my reference because I am rubbing the full board. For my reference. Right now, do not see this one. Don't bother. You right now, you stop here now. Continue. I will start from that corner and start the question. Okay. I will, but to save the time once again, numbers I will prepare first. Continue now. See, our last statement was shear reinforcement was required to be designed. Therefore, this is the real question where your inclined bars will come into picture or that cranked bar will come. First 2 questions are just for understanding only. Okay, start. I told you, design is for vertical stirrups. See, yesterday I given procedure, right? So, continued. Let us provide 2-legged 8 torr vertical stirrups. Vertical stirrups are always there. Okay, now, as per IS code, spacing of vertical stirrups SV, sigma SV ASVD by VS. This you know already. Now do one thing. I told here vertical stirrups is a shear reinforcement. Even cranked bar also shear reinforcement. So what we will do is what we used to call earlier ASV and VS, we will add extra suffix here ST and ST to differentiate stirrup with cranked bars. To differentiate them, we'll put extra. Okay, start. Sigma SV permissible tensile stress in shear reinforcement. I already told you should not take more than 230. For FE 500 steel it comes 275. So you have to take 230. This already I told earlier. Then ASV means what? Oh, sorry, one more thing here. ASV ST stirrup is area of the stirrups 100.53. You know it. Pi by 4 of 8 square into 2. Okay, right there. Cross-sectional area of the legs of the stirrup into number of legs. VS, see now instead of VS, it is what? VSST. How much shear force to be resisted by vertical stirrups? Earlier all VS equal to V minus VC. Now VSST. Stirrup have to take shear force V, subtract shear strength of concrete, also subtract the other one. What is that one? That is other one is other one is shear strength of cranked bars. Now this is see additional help from the total shear from the shear force. Subtract the strength of concrete. I will give money matter. Subtract strength of cranked bar. Now we see as usual shear strength of concrete without shear reinforcement tau CBD. This you already know it. Now the new term. Earlier what you do? V is known, VC known. This was not there. Substituting at VS, substitute in the formula and get the spacing over. But now not that way. VSCR is a shear strength of cranked bars. I told formula, all green color. VSCR is sigma SV ASVCR sin alpha. As usual, sigma SV is 230 only. Same as sigma SV already came here. For shear reinforcement already came 230. So once again not required. Then ASVCR is cross-sectional area of cranked bars. In the question told 2 bars of 16 torr available. I think in the question I given 2 cranked bars of 16 torr available. Pi by 4 of 16 square into 2, 402.12. Alpha is the angle I told last time. Take alpha 45 degrees, substitute sigma SV, ASVCR sin 45 will come 65.4 kilonewton. Now one thing, something in the class I will dictate. In the class. There is an IS code condition. See, red color I wrote. If that condition is not there, what it means? Shear force is 200, concrete can take 40.7, and stirrup can take, cranked bar can take 65.4. Subtract, you get the shear force for the stirrup. But IS code told shear strength of cranked bars. See, cranked bar is a guest. It is not there always. But stirrup is always there. IS code is giving more importance to stirrup, not cranked bars. They want to give more importance to stirrup. So what they told is shear strength of cranked bars shall not be taken more than half of shear reinforcement, half of shear strength of total shear reinforcement. Shear, see, V is the shear force. VC is the strength of concrete. When you subtract, what you get? How much is the shear force to be resisted by combined shear reinforcement? It's half. VSCR, this value, you should not take more than half. Or, I will explain once again, not more than half of 200 minus 40.7, it comes to 79.65. So now IS code condition is, this cranked bars, whatever you provided, it is a contribution, you should not take 79.65. But VSCR calculated is 65.4. Only 65.4 is there. So, see, actual available strength is 65.4. IS code told you should not take more than 79.65. But available strength is 65.4, which is less than the limit. So, we have to consider VSCR equal to 65.4 10 to the power 3 Newton only. 1 minute. I'll give example for you. I'll complete first. Substituting VSST equal to 200 minus 40.7 minus 85.4 come to 73.9 10 to the power 3 Newton. Okay, now last step I'll complete here. Substituting, so that I close the question. Substituting SV for what? For vertical stirrup equal to 230 into 100.53 into 500 divided by 93.9 10 to the power 3 Newton equal to, I should check the camera once. I think it is okay, visible. Oh, fully visible, no problem. I made a camera little adjustment. That will come. Don't worry, I will explain. I want to close the question. 230 into 100.53 into 500 divided by 93.9 10 to the power 3. 123.12. 123.12 millimeter center to center. Okay. Now, one important information. This is the design strength. So, for this beam, vertical stirrups should be provided at a spacing of this all I told earlier. Either at 123.12, this is strength based. See, I told you, this is strength based. How many times I told? Strength based. If you want, you can give it closer. You should not make wider. Okay, now, this is required, not required. Okay, leave it. Now, one thing. Now go to IS code. Oh, here, see, that's why I maintained. As per IS code, for vertical stirrups, maximum permissible spacing is 300.75D and this formula. See here. Here, FE 500 steel. So, Fy equal to 500 Newton per mm square. Right here. But IS code told Fy not more than 415. Therefore, substitute Fy equal to 415 Newton per mm square only. So, this will become 100.53 into 0.87 into 415 divided by 0.4 divided by 200. It will become, camera problem. So when I go to right side extreme corner, I get worry. Okay, no problem. Tomorrow no one should comment, sir, board is not visible like that. 100.53 into 0.87 into 415 divided by 0.4 divided by 200. 453.70. 453.70. Now do one thing. Don't see here. Therefore, as per IS code, maximum permissible spacing for vertical stirrup is 1, 2, 3 values are there. Least of them is 300 mm center to center. Now do one thing. See, but designed spacing is 123 right here. IS code told you should not give spacing more than 300, but strength based came 123. So compare this designed value with the limit and provide the least one. Therefore, provide 2-legged 8-tor vertical stirrups at 123 is there. Round off. 125 you can't make. At 120 millimeter center to center. Okay. Now, question is over. Now do one thing. I will tell you some concept. So understand. If your confusion is there regarding this one. See, I will tell money matter first. This I will remove. Okay, I can remove this one. Once again, same thing. See, suppose you have, last time I am telling, 2 lakhs with you. 2 lakhs with you. This is concrete strength. Now remember, not how we know, now force language. Now it is a force language. Force language. This is equal to VC. How much shear force concrete can take. Okay. Now, V is the cost of the car. Cost of car. And your friend, which friend? Your close friend. Close friend. Here it is vertical stirrup. Because vertical stirrup is always there. Inclined bar sometime will come, sometime may not. 99% inclined bars are not there. Very rarely you get it. So rare case. He is your close friend, regular friend, close and regular friend. He told, I can give maximum 8 lakh rupees. He told maximum. Therefore, total you can buy how much? 10 lakh. Okay. Now, first question, you want to buy 15 lakhs. Over. Not possible. Redesign. Second question, you want to buy 1.5 lakhs. You yourself has got 2 lakhs. Then why you want help first of all? Sheer reinforcement not required. Friend is not required. Friend is not required at that time. Now this case, imagine, okay. Imagine you want to buy a car, which will cost you, 8 lakh, 7 lakhs. 7 lakhs you want to buy a car. Okay. 7 lakhs you want to buy. Now, earlier cases, how much is the VS? That is stirrup. How much strength stirrup required? 7 minus 2. Or stirrup means how much, I should not tell stirrup here, how much money you require from your friend. You want to buy a car of 7 lakh. See, earlier all we take, this was not there earlier. This was not there. V minus VC. You require 7 lakhs. You got 2 lakhs with you. 5 lakh rupees is the loan required earlier. But now, there is a new friend whom you came to know today only. Maybe he is staying next to your house or in the same building. He came to know about that you are buying a car and you are arranging the money. He told, I can also give some money for you if you want. But remember, you should not forget your old friend. Very important. Why? He is always there. Stirrup is always there. IS code wants to give more weightage to stirrup. So you want to buy what? You want to buy 5 lakhs. 5 lakhs. Usually you call your friend, usual friend, good close friend. Hello, I want 5 lakhs. Can you please give me? He told, okay, I will arrange and give you. Then this new friend or new person, he will ask you, that is an inclined bar. He will ask you, you got some fund requirement, I can also give some money. Okay, how much? We don't know. He told, I can also help you. He told, I can help you 2.2 lakhs. 2.2 lakhs I can give. Now see, what IS code told is, you should give important to your close friend. This new friend or close friend together, you want to raise 5 lakhs. You should not take money more than 2.5 lakhs from this person. Why? Suppose imagine, 1 minute, this person offers, he tells, he got 3 lakhs. He got 3.5 lakhs, he will tell. He told you, I can give you 3.5 lakhs. Now, if you take 3.5 lakhs from him, from the 7 lakh car, 2 lakh you already got. So your requirement is extra loan requirement of 5 lakhs. If he gives 3.5 lakhs, your usual close friend, you have to take 1.5 lakhs. He will feel bad. Oh, just because a new person came, he is giving more important to him and less important to me. Or suppose he comes to know that you are taking help from near another person. Maybe he will tell, okay, take it. It will be better for me. But he put a condition. You should not take loan from him more than half of your requirement. See, your requirement is 5 lakhs. Should not take loan from him more than half of your requirement. Therefore, 7 lakh required, 2 lakh you have got, 5 lakh, half of 5 lakh is 2.5 lakhs. He told, I got 3.5 lakh. You tell him, okay, thank you, but give me only 2.5 lakhs. Remaining 2.5 lakhs, you take from your close friend. Now, by chance, see, but here what happened is, VSCR came 65.4. Limit is 79. Like, the new friend, he told, I got 1.5 lakhs. Okay, then you need 5 lakhs extra money now, loan. He told 1 point, you can take. Why? Because your friend, close friend told, give more important to me. Don't take money from him more than my money. So okay, no problem. You tell him, a new friend is offering me help of 1.5 lakhs. Okay. Then you take 1.5 lakhs from him and 3.5 from your friend. See, because as per friend condition, you should, if you require a loan of 5 lakhs, that is V minus VC, 50% of that one. So if you require a loan of 7 lakh minus 2 lakh is 5 lakhs divided by 2. If you want a loan of 5 lakhs, you should not take more than 2.5 lakhs from him. But if he tells you about 1.5 lakhs, how we can give 2.5 lakhs? If the new person has got only 1.5 lakhs, take it, no problem. See, cranked bar strength is 65.4. Limit is 79.65. So over. Now, by chance, make a note here. Instead of 65.4, if it is 85.4, what to do? Then 85.4 you cannot take. You have to take it as only 79.65. If your new friend offers more than 2.5 lakhs, take only 2.5 lakhs. Or finally you can do one thing. To avoid all this confusion, I will tell what to do. See, single statement. I write here. Correctly write. Find VSCR. VSCR by the formula. Which one? VSCR equal to sigma SV ASVCR sin alpha. Then find that value. Get this value. Then find half of V minus VC. Then VSCR to be considered is one of them is either calculated value of VSCR or half of V minus VC among the two, whichever is least. This is a last option. Simple language. Either 2.5 or whatever he got, whichever is least. If you got only 1.5 lakhs, you can take only 1.5 lakhs. But if he tells I got 3.5 lakhs, take only 2.5 lakhs. So either this VSCR calculated or this conditional value, compare these two, take whichever is least. Okay, that much information is sufficient. Okay, over. Now, design of shear reinforcement by working stress method over. Next, I will upload design of shear reinforcement by limit state method. Little later, I will also upload limit state, most important, limit state method analysis of single EW and T-beam. I talked with the batch today. They told, okay sir, please upload in the YouTube. We will follow from that one, because if I take class in Zoom, it will be deleted. If I upload in YouTube, they can refer anytime. And general public also useful. Okay, thank you. See you in the next class. Go through everything and thoroughly understand.